Hello everyone, Microbehunter here and welcome to another Saturday live stream. And last week, probably some of you have already realized I did not have a live stream, and the reason is because I was not home. I was on holiday and I took along a couple of samples that I would like to put under the microscope together with you. Most of the samples I have not looked at yet because I just returned from the holidays the day before yesterday. And yesterday as a matter of fact, and I would like to put them under the microscope together with you, and so the things that we're going to see is also going to be the first time that I'm going to see them. You can already see here a map from Google Maps, and you can see here that I spent 1 week here in northern Germany on the Baltic Sea. It's the Baltic Sea over here. And there where there is water, there is life. I always used to say, and therefore I took along a couple of specimens from the Baltic Sea, and I would like to put them under the microscope. As a matter of fact, we're going to look at a couple of sand samples, feather from some birds, and I also found a couple of microorganisms there that I would like to show you. So that's kind of the idea. I can show you if you want. I can actually show you the desk, some of the specimens that I have here, okay, that I'd like to put under the microscope. And over there I still on the side I have a glass jar with some algae and some seagrass, and it started to rot a little bit and the microorganisms started to multiply. I've seen now that several people already started to sign in and to chat, what I would like to ask you, if you're new here, if you have any specific question, then please which is directed to me, then please make an @ Microbehunter so that I know that you're talking to me, because sometimes viewers like to chat among each other as well and ask questions and answers there. That's fine, but sometimes it can be a little bit difficult and to filter out which questions are directed to me. So please put an @ Microbehunter there so that I'm able to find your comments more quickly. Yes, I see that there is already a hello from New Zealand, from Vietnam, from the Netherlands, from Brazil, from England, from Canada, from Norway, Tennessee, New Jersey, from France. Yeah, somebody's talking also, and from the Ukraine. Yeah, so from all over the world, hello, greeting around the world. From Canada, I just see here. So, and what I would like to do is the following. I'm going to simply start putting some of the things under the microscope, and later, maybe towards the end, I would like to put a water sample as well. This is the only one that I actually already observed because I always almost wanted to throw it out because it started to smell so badly. But luckily, there are lots of microorganisms still present. So I just wanted to show you also a couple of things here as a little brief introduction of what I have done where I have been. And so I prepared a small video each time that I would also like to comment and narrate. And then I would like to put some of the samples under the microscope. And for example, I've got 2 sand samples over here. And I would like to make a permanently mounted slide of sand. So I'm going to also show you how to do that. Here is some seagrass, some dried seagrass, some bird feathers. So let's get started. I'm going to show you first a quick video of where I've been. So that is basically the first day. The weather was not so, it was a little bit windy, but it's environment from the nature is very nice. And this is a pretty scary place because they had very steep cliffs. And if you walk there, there's always the danger of falling off. So I was already very dizzy. I did not dare to go any closer. And seen from the bottom, it's quite steep. So we walked along there, and here on the bottom you can see some seagrass, some sand as well. And this is also where I took some samples. So you can see that it goes up quite high here. Okay. This is basically the place that I've visited, or actually one of the places. And you can see also erosion and the water kind of washing away the earth and the soil. So this is basically what was one of the places where I was here. Again, you can see quite a bit of seagrass. They removed it periodically so that you could actually also use the beach then of course for recreational purposes. That's another thing I want to show you later on. Okay, so what I would like to do now is because I did collect a sample as well. Let me quickly, it's the seagrass, That's the feather, yeah. And we're going to have a look at some sand samples as well. So you see I prepared a couple of videos here. So what I'm going to do now is I would like to first have a look at some of the sands that I've collected here. Again, I do not know what to expect, and I'm just going to try to put it under the microscope, also under the stereo microscope here. Okay, yeah. So there is also hello from Poland, from England, from Sheffield. Okay, yeah, and. Yeah, okay, so that's basically where we are. So I'm going to do the following now. I'm going to need a piece of paper, and I would like to make now a slide, a permanently mounted slide of the two sand samples here. And what I like to use here, I mean, there are different ways of how you can do that. One possibility that I have here is this is a slide which is concave, so there are indentations, and what I've done here is I put some sand into here. So this is not the sand from the Baltic Sea, so this is an older one. And then using some nail polish, and that's the blue color here, I glued on the cover glass. And basically this is one possibility, and this actually shows the sand in its very natural environment, surrounded by air. And if you want to look at this here, but again, this is not the one that from the Baltic Sea, but the one that I've prepared already before. And then you can see over here, the sand grains, and we do a little bit of focusing here, okay, and that's basically shows actually the sand grains quite nicely here, okay. And of course if you shake everything, then it will again appear differently. So that's actually one possibility. Now that was actually the only slide that I had with two indentations. So what I've done is I ordered myself some more slides here, and they only have one indentation. You can see it's only one place in the reflection in the light, you can see that. But then when I got them, I found out that actually the indentation itself is not very deep. The slide itself is not quite as thick either, and the indentation is not very deep, so I don't think that this is going to be deep enough to actually put some sand into here, because the sand grains also have a certain size. So this is a little bit unfortunate, so I decided to try a different way of doing that. And in order to do that, I recommend the following strategy. You take yourself two slides, and all I'm doing right now is I'm simply going to glue the sand. I'm going to glue the sand on the slide using some glue. Okay. So what I suggest is that we actually fold the paper in half, so that it's also easier later on to remove the sand again. And what I would like to do now is simply the following. I place the slide here, and then I'm going to put a drop of glue. You already know this glue, obviously, because I've been using it already before. And I'm just going to put a drop of glue here on the slide, and then using a second slide, I'm just going to spread it across. Okay, maybe that's maybe the other direction here. I'm going to simply spread it across. Okay, and then you have guessed, all I'm going to do now is I'm going to dump the sand over the slide. You can see that the sand itself is still a little bit moist, and that's okay. It's, because it's not quite dry, it's not wet either, it's a little bit moist, but that's okay because the glue itself is also water-based. Okay, and then normally what you would do is you would just let it dry. Okay, so and then you do it like this. Okay, and then you would let it dry, and the rest of the sand goes back into the container. Okay, so I think I'm just going to do that as well now, because I don't want to have any sand flying around. Okay, I might need a second piece of paper in case I spilled some of the sand. Okay, and now that's why it was important to fold the paper. And it goes back in. Okay, so that's basically slide number one. And now I'd like to have a look under the microscope. Okay, and let's first have a look under the stereo microscope. So here we go again. Yeah, and here we are. Let's always zoom out a little bit. Okay. Let's focus a little bit. And I see that the background is white, so maybe I'm going to just flip it around. Maybe this is a little bit better. Okay. And one of the reasons why I'm doing this is because I would like to compare the shape of the sand grains of this sample with the other sample that I have here, because this is actually artificial sand. We'll tell you later on why this is artificial, and here we have basically the sand grains. Okay, and if you now let it dry, then then you have a permanently mounted slide. So this is one way of actually also looking for tiny seashells and so on. And I did a little bit of research, and the sand, of course there are different types of sand, but the sand in the where I collected this is mostly so-called, because there are no coral reefs there, so the sand here is from rocks, from erosion. And not so much from seashells. There are different types of sand which are also more, which contain parts of seashells, but not so much here. Okay, so these are basically rocks that have eroded. Yeah, so this is basically how it looks here, and if we zoom in a little bit, but of course later on, or not later on, just in a second, I would also like to show you how it looks under the compound microscope. Now you can already see a little bit the advantage and maybe also the disadvantage of this method. I'm going to now activate the arrow a little bit, because one of the disadvantages is, of course, where is my arrow? One of the disadvantages is, just a second, nope, I'm looking for my arrow, here it is that you can still see now between the sand grains, you can see the glue. Okay. Now, as the glue dries, it will retreat a little bit, but yeah, so that's a little bit of an artifact, so to say, that you have between the sand grains. You have, of course, the glue, and this kind of makes it appear not quite as natural as maybe as the other one. Yeah. And I just am seeing right now that for whatever reason, my camera stopped working, which is a little bit of an interesting thing here. Every now and then, my camera stops working, which is a little bit annoying. And then I have to deactivate the camera, and then I'm going to activate it again and hope that it jumps back to life, and it's back to life again. Yeah, the reason why it deactivates, I don't know, but sometimes I think the reason could be that the computer or the USB system is a little bit overloaded, because I've got so many cameras connected that it might be a little bit overloaded. Yeah? So that's basically under the stereo microscope. Of course, you can now try to do this and look for other interesting things like microplastics. Unfortunately, that's a big topic these days as well. But I think you get the idea. So that's basically one way of making a slide. Yeah. So I already see there is a comment here. Is this actually under the stereo microscope? Yes, this is under the stereo microscope. I don't have another camera where I can show it to you, but I have on my left side, I've got a stereo microscope, and on my right side I have my compound microscope. You know? And I've got each one with a camera, and that's why I'm able to switch around. Okay. Because I've got this. If you want to know more about this particular stereo microscope model, in my other channel, in the one that I call Microbehunter Microscopy, I did a review of this one. It's the Nexius Zoom stereo microscope from the company Euromex, and it's a pretty nice one, and it basically has a continuous zoom, as you can see here, and of course I have to occasionally refocus. Okay, so let's have now a look under the compound microscope. Okay, that's some seagrass from which we're going to have a look later on in more detail. So so that's basically now you have also the camera here, the other one, and this is how it looks like. Not quite as nice, I think. And here you can of course see also that there is now the glue present as well. I'm going to put in the polarization filter as well. So that's basically how it looks like. The colors are because of of the polarized light and the contrasting technique that I'm using. If I remove it, then it looks at this bright field. It's quite remarkable how different it looks, and that actually shows I would say the advantages of stereo microscopes. If you don't have a stereo microscope, what you can do is I'm using now the full power objective, the low magnification objective. You can of course also turn off the light and use a flashlight to shine it on from the top. This also works. So I highly recommend this. I also made videos about this already before. You just use the low power objective. There's sufficient distance, and then you use a strong flashlight, shining light from the top, and then you're also able to see it quite nicely. Yeah. So that is basically something I wanted to briefly show you. So far nothing really unexpected, but what I could do, just I mean, I don't know, I do have some little I do have some what do you call this, little petri dishes here, so I might as well also have a look at it without, maybe that's also a possibility, without the glue. And it's still a little bit moist, so the sand likes to stick together. So let's have a look how this looks like. Okay, of course I have to go to stereo microscope, and here we go. Yeah, and usually you have to look at it using a slightly lower magnification. Yeah, and then you can look for more or less interesting things here. But what I really am interested in is more the shape of the sand grains, and they are rounded here because of the wave action. But I think the sand, as I was told, the other sand sample that I have here should be a little bit more irregular, the shape. So yeah, so many mysterious stuff in the sand: microplastics, shells, plant materials, sometimes fossils. Yep. Yeah. So there are basically a lot of interesting things here. If you want to observe sand more, you need to take more time. I'm just basically just giving you a quick intro here. So I just want to demonstrate something here as well, a little bit of interesting theory. Let me adjust the light here. Look, as I'm focusing up and down, I'm just saying this that you know, in case you're surprised. I'm just focusing up and down, but you actually also notice that the image shifts left and right as well. Okay, that is completely normal. The reason is because the one objective that is used to direct the light to the camera is there are two objectives in a stereo microscope, and only one of them is used to get the image to the camera. And as we're focusing by moving the objective up and down, because it's not centered, because it's off axis, this gives the impression that the image is shifting left and right. So if you want to do some image stacking, the software will actually, or focus stacking, the software will actually correct this shift. Okay, I just wanted to clarify that this is completely normal in stereo microscopes, that when focusing up and down, the image also shifts left and right. Okay. Can you try to do dark field under the compound microscope? Okay, yes, this I can do that. Let me quickly check. I have one filter, and I think this, let's see if this works. I think, I don't know if this actually works or not. Yeah. This would be dark field. See, it doesn't work in my case. This is actually the phase contrast. This is actually the phase contrast ring, which can also be used for dark field, but I don't have a dedicated dark field system here. Yep. So you see that for sand it doesn't work. It's interesting. Okay. For sand it doesn't work. And let me try this here. And nope. I'm adjusting the condenser now. Yeah. Not so much. Okay. Yeah. Interesting point. What I would like to then therefore do, I'd have to. My microscope is actually not equipped for dark field. It is possible to get a dark field image by using the phase contrast annulus, but it doesn't work quite well in this case here. Okay. Yeah. And now I'm not seeing any image at all. Why is that? Okay. Yeah. Because of the wrong filter. Okay, here we go again. So, okay, so this was basically, yeah, thank you for accepting my topic suggestion last time, although I couldn't watch live, I did see it live streams. I don't remember, yes, thank you for the thanks, but I don't remember which topic suggestion I considered and accepted, I forgot. But yeah, I'll just go on now, and I will put this sand here back again into the, where is the desk? Here is the desk. I want to put the sand back in here, and I better get the correct container. I just also want to say that be careful when collecting sand samples. This is not legal in all countries. In Italy, they have very strict laws. They can actually be fined yeah, if you collect sand from beaches. So always inform yourself if collecting small amounts of sand is allowed. I know that in Italy, on some islands, yeah, some tourists have been quite severely punished because they've taken sand, but at the same time I've seen that they have taken quite a large amount of sand as well. Okay, so now let's have a look at the second sand sample here. Okay, you notice that the color is a little bit different, and before I basically put this under the microscope, I wanted to show you also another video where I collected it from. I forgot where it is. No, that's for later. The seagrass, yeah, that was basically the feather. Yeah, here we go. Look, these are sand sculptures, and there was a sand sculpture exhibition for the 5th year already, and all of those things here are made, yeah, of this sand here that I have, and this was actually done by international artists, and this is an exhibition, and you just basically can visit this. And look, I think it's quite amazing of what you can do. And the sand has been compressed. So what they've done is they watered the sand, so they made it moist, and then they used machines to really press it down into blocks. And then they basically, the artists could carve out those sand sculptures. And those sand sculptures are extremely stable. So that means even though this was inside a building, even when it's raining, then they can withstand even rain, and heavy rain even. So the sand is that condensed and compact. And at the exhibition, every year they have a different topic. This year's topic was movies. So that's, I think, a scene from Star Wars. Yeah. So they have different movie scenes, and then the artists were given the sand and to make a sculpture, and then basically it's an exhibition. This particular sculpture here was actually standing outside. And a German couple was actually watched me while I was looking at it, and they said that this sculpture has been standing outside for several months now, and was even able to survive a heavy rain and storm. Yeah, so the sand is that compact, and the reason why it's that compact is because this is not sand from the beach, but this is sand from a quarry, according to the information that I read, is that the sand grains are much more irregular and sharp-cornered, and those sharp corners, when you make it compact, apparently causes the sand grains to interlock with each other much better, and this gives the sand such a strong consistency. Yeah? So that's Indiana Jones sculpture. You see in the background, you can see the rolling ball and so on. So these are all movie scenes. Okay, so this is basically the sand, and I collected. Yeah, there was also a sandbox there for children to play, and there was so much sand lying around there, and I took from the a little bit of sand along, and I would like to put that under the microscope now as well. Yeah, so there was basically some sand washed. So obviously you don't do any damage to the sculptures, but there was some sand that was washed away from the rain, and basically this were collected some of the sand here. Okay, so because and let's have a look now. I would like to do the same thing now. I would like to put it under the microscope, and I'm going to just put it directly under the microscope first. And let's make another. Permanent slide as well. And you can already see that this the sand, looks much more orange. So, and let's have a look now. And let's focus again. Yeah. And I also see that the difference in the size of the sand grains seems to be much more. Yeah. Interesting. You see there, or maybe you just see it better here. There are also some fibers, yeah, present as well. Yeah. Where is the? Just a second. Let me quickly. Here it is. Yeah. So you see that there are some other things present as well. Yeah, and yep, and it looks indeed like that the more large and smaller ones, so they're not quite all the same size. Yeah, and apparently this sand is significantly better for making those sand sculptures. So I would not expect anything interesting here, like shells or tiny forams or whatever that you sometimes can find, because this is from a quarry. So I suppose that they got the rocks and maybe they crushed the rocks and yeah, to make the sand. So it's I think it's artificial sand. But again, all of those, plenty of those fibers in here as well. Wonder how they found their way into the sand. Could be maybe that they were introduced by rain and yeah, by wind and weather. Okay. Yeah, just a couple of questions again off topic. I also watched the Paramecia on chili short. So interesting. How do you get the hot chili off your fingers? Whenever I touch chilies, the hot sting lingers even though I wash it off your fingers. Really? Do you actually feel the hot chili on your fingers? What I would suggest is that you try the following. I've not tried this yet. It's a little bit of a guess. If you're not able to wash it off, then it could be maybe that the substance that causes the burning maybe is hydrophobic. So try to add a little bit to wash it off with a little bit of oil. Because it could be maybe, it's a speculation, it could be that the oil washes this, dissolves the substance better, and I think so because there is, if you eat something very spicy and if you want to soothe it off, then you can drink a little bit of milk, and I think that it's also the fat in the milk that is able to dissolve and remove the spiciness. I'm not sure about this, but that's a little bit something that you might want to try. Okay, so yeah, so let's make another slide here. So I need to find my slides, and this slide here is not particularly nice. These are all washed slides. I try to reuse the slides by rinsing them and by washing them with some dishwashing powder. Okay, and let's give it another try. So let's a little bit of glue. Here is the slide again. Okay, and where is the sand? Let's dump the sand over it. Actually, oh yeah, here, let's just use this here. Okay, same story. And yep, here we go again. Okay, so let's put it again under the stereo microscope. The advantage of having it on a slide is that yeah, it's a very flat sample. But here we see already maybe one of the disadvantages. You see that some of the sand grains are soaked in glue. You see it here on the reflections, but maybe when the glue dries, yeah, you won't be able to see it anymore. You won't be able to see the glue quite as much anymore, because as the glue dries, it starts to shrink. Yeah, I guess you get the idea. Okay, so yeah, I'm gonna move on. Enough about sand, I would say. Let's have a look at some of the other samples as well. And if you have any questions, then please do feel free to ask them, even if they're a little bit off topic. Okay, so let's put it back here again. The desk is here. So that's basically number yeah, sound number 2. So I'm going to put it somewhere over there to get the tubes out of the way. By the way, the tubes that I'm using here, these are centrifugation tubes, which I ordered, and they're quite convenient because they're watertight and they allow also light to go through in case you're transporting photosynthetically active samples, algae and so on. They need light. The disadvantage of those specific ones here is that yeah, they're conical here, so it means you're not able to stand them up. Okay, there are some of those tubes that have basically are cylindrical here, so that you're also able to stand them up. Okay, yeah, here I've got an example. Yeah, so they come in 2 different versions. And you see over here, this one, yeah, allows to, yeah, you can stand it up, and this one over here not. Yeah? So I'm just saying. Yeah? So let's have another look now at, I'm going to show you another video now. Yeah, we already watched this one here. Yeah, I'm going to look at later. Seagrass. Yeah, this one over here. Birds, there were plenty of birds there. This one was quite friendly. And where there are birds, there are bird feathers. So I would like to put a bird feather or 2 bird feathers under the microscope. And bird feathers are hydrophobic. So this basically means is they do not like water. Yeah, and I'm going to now show you how you can still observe them by, yeah, without having too many air bubbles forming. Yeah? So I found those 2 feathers and I took them along. And birds have, yeah, there are 2 different types of feathers. There's so-called the down feathers, and then there are the feathers that are used for flying. Yeah, and yeah, here they are. Just a second. Here we are. Here we go again. Yeah, yeah, so that's the one feather here, and I would like to use the down feather. This one over here. Okay. And what I'm going to do now is that I'm going to actually cut off a piece and I'm going to put it under the microscope. Okay, so and then I hope that I'm able to demonstrate that what I wanted to show you, namely that if you use water as a mounting medium, that there is a little problem with that. But you know what? Why not first look at it under the stereoscope? Because yeah, so that's basically. Yeah, the feather, and here you can, yeah, under the compound microscope you can actually see that the feathers, the strands, they have little tiny hooks that allow them to interlock with each other to make sure that the whole thing is also airtight. Yeah, yeah, so there are tiny hooks that yeah, allow, yeah, the feather to kind of hold together. But what I would like to do now is I would like to yeah, cut off a little piece here and make a mount, and let's see how this actually works. I need some scissors. Okay, and I'm going to use water as a mounting medium. Okay, here it's a little difficult to see white on a white background. It's not so easy to see. We put the paper away. And let's have a try here. I'm just going to cut off a piece here. And let's put it on here. Okay. And yeah, I need now, yeah, great. I need some container. Unfortunately, I forgot my container, so I have to wipe out one of those little, yeah, little petri dishes here, because I don't want to. I'm just going to use my t-shirt right now to do that. Okay, I think that'll be fine. Let's add a little bit of water here. Where is my pipette? Here it is. Let's add a little bit of not very much. Okay. And let's try to put a cover glass on top. Okay, and let's have a look at it under this time under the compound microscope. Okay, and let's have a look how it looks like, and hope that I'm able to demonstrate that what I actually wanted to show you. Oh yeah, this is of course way too bright. Well, actually looks better than anticipated. But what we're able to see a little bit here is that, here we can see it better. You can actually see that the feather sticks together quite a bit. Okay, and the reason is because the feather is hydrophobic. And it is covered in a very thin layer of fat or oil or grease, and this kind of water protects the birds. And consequently, water does not like to be in contact with the feather, and sometimes what you're able to see then is that there are a lot of air bubbles present, or that the individual or the feather starts to stick together to minimize the exposure to the water. Okay, so this is basically one of the things here. You can actually see that there might be a little bit you can see actually that some air bubbles disappearing. Okay, but let's try the whole thing now again using oil as a mounting medium. Yeah, so let's maybe we're able to see something different. Now I've tried feathers where you're able to see the effect much better. Then here I've put some feathers under the microscope with water, and there were huge bubbles, and it was very difficult to remove them. But once you used oil, it was actually no problem at all, and there were no bubbles. But let's have a look now how this actually looks like using oil. Okay, so what I'm going to do again is I'm just going to use the same slide. Yeah, let's cut again some pieces off here. Difficult. Okay, so maybe a little too small. Okay, here we go. So, I've got some cooking oil. Actually, it's olive oil that I've got here. Can be pretty much any type of cooking or vegetable oil. And theoretically, you can even use immersion oil. But probably not worth it due to cost. And I'm going to now add some oil here, and let's see if it looks different. Because normally what we would expect is that the individual the feather kind of spreads a little bit better. This is kind of a little bit the expectation that I have. Now let's see if this is actually also the case. So let's have a look here. Okay, that's not the one using oil. Okay, I think the difference is quite notable. Okay. And again, here that's the one in oil, and this one is the one in water. And you see it kind of tries to minimize the exposure to the water, and therefore the individual parts, they stick together. And here that is in using oil. So a little demonstration here of the importance of mounting medium. That the mounting medium should be compatible to the specimen that you're actually observing. So there's another comment. I collected a sample of Baltic Sea water with a bit of weeds 3 weeks ago and regularly observing that samples since then. What is the best way to identify the names of microorganisms which are grown in it? That's always a challenge by using an identification book. And also knowing that sometimes microscopy alone might not be enough to distinguish different species that look very similar. Okay, but there are identification books out there. But due to the large number of microorganisms, one should not be surprised that there are maybe also some microbes present that are not in the book. Biodiversity is quite large. So that's basically the feather now using oil and using water. Okay, so again, mind your mounting medium so that you get the best results here. Okay, so the next thing, let's see if I've got another video here. There's another question here. I think I will try the feather in oil tomorrow. Most birds here are seagulls and pigeons though, yeah. But it doesn't, I think it doesn't really matter because yeah, the feathers of a bird have to protect the bird also from moisture, and if the feather actually soaks up the water, then yeah, it's also a matter of weight, yeah? Because you don't want to have carrying around too much water. Okay, so for this reason, when you the birds when they can't become wet because the water drop simply runs off. Yeah? So let me show you something else. Yes, yeah, that's there was a little place there that I could visit, and they had aquariums there. They had workshops. And there was also, yeah, so especially also interesting for children. In school classes could go there, and yeah, they also had a starfish. I took it out, or yeah, it was given to me. It's kind of interesting. If you turn around the starfish here, you can see the tiny little legs moving around. Now I did not put that under the microscope. Just wanted to show it to you that they had this station. They were basically. They gave some marine biological information here, and it was a quite interactive and quite fascinating and interesting workshop that I participated. But the really interesting thing is and I'm going to pause the video here. This is actually on screen. He collected some plankton and put it under a stereo microscope, and then over a camera it was projected on the screen. So I was just with my mobile phone filming the screen, the video projector. Therefore, the quality is not so good. Yeah, but you could actually see that there was plenty of stuff moving around there. And this is a stereo microscope. So yeah, so he was kind of demonstrating yeah, of all of the microorganisms that could be found there. And yeah, I'm also going to show you a couple then. Okay. So yeah, this here is not seaweed, as I was told. It is so-called seagrass, and it is actually related to the terrestrial grass. So these are not algae, but it's called seagrass. And what I have is yeah, there were lots of seagrass also floating in there. This was actually dried seagrass, dead seagrass that was swept again into the water. And there was plenty of this seagrass also on shore. And yeah, there were also, of course, some algae present as well. And yeah, here you can see quite a bit of this seagrass on the shore. And it was the beach was cleaned regularly, so that it could be actually used again by yeah. And this is also some of the seagrass mixed with sand. And what I wanted to do is I wanted to say, okay, that's pretty cool. I'm going to take along some of the seagrass. I have done that, and after a little bit of research, I found out that this seagrass is was in the past very versatile. So they used it as stuffing for pillows, for example. It was used for insulation material in houses. It was apparently also used as food. It was used for all sorts of different things, for making roofs of houses even. Yeah, because in a dried form it's very yeah, resilient, and not resilient, but it's very yeah, very stable. Yeah. Yeah, so that's basically what I've done. Is I've collected some of the seagrass. I have to tell you, under the microscope, it does not look very interesting. Okay, I took it along in any case. I can show it to you in any case. It's not super interesting, also because the leaves are fairly thick, so that means it's difficult to see the individual cells, and they're fairly dark. Okay, but yeah, I've got yeah, one of the samples here, which I already made before I started this live stream, and the reason is because I want to give it a little bit of time for it to soak up the water and the moisture. Okay, I might have to add a little more water here. Let me add a little bit more water here. Okay. Yep, and let's have a look at it under the microscope again. Yeah, and that's basically dried seagrass, and yeah, as expected, not very interesting, specifically also because of the fairly thick nature of the grass. Okay, so where is it again? Here it is. Maybe if we zoom in, we're able to see the individual cells here. Those tiny little structures that look a little bit like bricks. But yeah, but of course not quite as interesting as if, for example, if you were to take a fresh plant, then you might be actually also able to see some movement inside the cells here. Okay, so so what I've done is I have taken along now a couple of specimens, also in those tubes here. Yeah, so I've got 2 tubes, and they're now empty because I've taken them out. So I filled them up with some seawater, and I took some algae and some seagrass. And I said, well, with a little bit of air in here, and I put it under the light so that photosynthesis can go on. I said, well, it's going to survive 2 days, hopefully, until I'm back home, and then it's not going to turn bad. Well, already after 1 day, when I opened it, it started to smell horribly bad, like sulfur. This basically means that there's decomposition going on. The plants did not look very nice anymore. And I put it under the microscope yesterday, and to my big surprise, the sample did not die, but microorganisms, primarily ciliates and bacteria, started to reproduce. So there is, it was quite active, and that's also one of the things that I would like to show you. But there are a couple of comments that I would like to talk about first, and there is, so I think I will try the feather, yes. So, microscopy 300 years, yes. Thank you for reminding me. Look, I want to now show you the screen here. Look, this is the web page, and look what we are able to see here. Okay, if you type in the hashtag microscopy 300 years and you search for it, okay, then you're able to see all of those videos that were tagged by you, the viewers, with the hashtag microscopy 300 years. Look, isn't this great? Yeah, and this basically, and there are a couple of YouTube channels on here that I did not even know about that they exist. Yeah, so this is really nice. Please type in the hashtag microscopy 300 years, and then you're able to see, many videos that the viewers have made. To celebrate 300 years of microscopy. And if you don't know what I'm talking about, I did show you before. I am proposing that we're celebrating 300 years of microscopy because 300 years ago, Anthony van Leeuwenhoek in 1723, that's when he died. He was the first microscopist, and I said it would be kind of nice if we would celebrate it by making videos, and if you put the hashtag next to your video, then people can actually search for it much more easily, and this way also videos and channels that are otherwise YouTube does not surface and does not show, because sometimes the channel is small, sometimes then YouTube does not show it so often, and but with this hashtag you can directly find all of those videos that the people have tagged. So it's an easier way to find videos that otherwise would not be so easily visible. Okay, so I would like to encourage you to keep on making videos, and also please do type this hashtag into YouTube, and then you're able to find a lot of these videos here. Okay, so again, to me, thanks to your inspiration, I started my own microscopy YouTube channel today. That's great. Please do post it. Okay, I think the reason why it's nice. A little bit of my personal approach here. If you have some kind of motivation, okay, you have a channel or a web page, it doesn't matter, and then you're kind of motivated a little bit to also keep on doing microscopy. So you're basically building on a channel, and then you also have a good documentation of all of your observations that you've made. Okay. So yes. Okay. So there are no more comments here for me. So that is essentially something that I would like to share with you. So next thing is the following. We're going to spend a little bit of time here on this here. This is the jar with the algae, and I have to tell you, it smells bad. Okay, I can show you here. It smells really bad. Okay. Wow, and I can already see that there's this white layer here on top, which was not present yesterday. So bacteria started to grow here. I'm not so happy about that. Yesterday there were lots of ciliates. It was quite interesting to observe, but this is not a healthy specimen, unfortunately. I wanted to actually have some healthy water plants, marine water plants, to observe, but it didn't work. Yeah, rather it started to decompose and it started to turn bad, and microbes started to reproduce. And what I'm going to do now is I'm going to pull out some of the specimen here. I'm going to put it on a microscope slide, and then later on I have to clean the pipette again because I don't want you to have bacteria and microbes contaminating everything here. Because as a matter of fact, you don't know what you're actually looking at here. Yeah? So let's try this. So what I usually do is these were some algae as well. And what you do, or what I've done is this, because it's way too much, but sometimes it helps a little bit by dipping it here. And yeah, it smells like sulfur, it smells pretty bad. Yeah, so yeah, there seems to be plenty of material now on here. I'll put it back again. Okay, I'm gonna put the pipette somewhere where I'm not going to touch it. And yeah, what about putting a cover glass on top? Here are the cover glasses. And then let's have a look. So here we go. And of course under the compound microscope. So let's go here, microscope. And we always start at low magnification. So let's go here, let's focus this a little bit. Yeah, it's still too bright. Yeah, I have to tell you the following. Yesterday there was significantly more life present. Yeah, now we have mostly bacteria, okay, but there are a couple of larger ones as well. So, okay, here at this magnification, okay, here we go. Lots of bacteria, okay. So of course a paradise for bacteria, but larger ciliates and so on, they feed on the bacteria. Yeah. It might be, the sample might be a little bit too dense. But what we see usually is a progression of different organisms. So yesterday I was also able to see some other ciliates, and yeah, new ones keep on multiplying, others start to die off, and since yesterday, yeah, a significant increase in the number of bacteria. And there seem to be a few dominant species that started to reproduce, these long ones over here. Yeah? Won't that much bacteria overfeed the ciliates? I remember you said do not overfeed, yeah? Yes, that's actually one of the problems why this is not a good sample. If you have too many bacteria in here which feed on the decaying algae, what's going to happen is, and so basically the whole jar is completely overfed. Yeah? What's going to happen is that they really push down the amount of oxygen. The bacteria, they use a lot of oxygen, and basically then some of the bacteria might even be able to survive at low oxygen concentrations. But ciliates and protozoa, they need a lot of oxygen, and if now the bacteria starts to reduce the amount of the oxygen concentration, and the larger protozoans, they can not survive either. Yeah? So this is indeed an example of way too much, and that's also one of the reasons why there are not so many different ciliates, or compared to yesterday at least not so many, because only a handful of them is actually adapted to the conditions that you have here. Okay. Yeah. So cool. What filter are you using? Wanted microbacteria. What filter are you using? Well, currently I'm not using any filter at all. The technique that I'm using is DIC. DIC is a fairly advanced technique, and what DIC does is it uses polarized light, and it's able to, yeah, you see I can change the colors around and so on, but it gives a little bit the impression of the specimens being three-dimensional. So for example, if you look here, where is this? I've got the arrow here. Yeah. If you look at this sky over here, you see that there seems to be a shadow on the bottom side, and it seems to be brighter on top. Yeah. So this kind of gives it a little bit the impression as if there is a certain amount of depth present. And DIC is able to do that, but you're able to get a similar effect using oblique illumination. There has been a request by one of my viewers to say, okay, can I not do a live stream also on oblique illumination, using oblique illumination filters? And I'm working on that, so I'd like to do that as well, but I need a different microscope for that. So I need to set up a different microscope so that I can illustrate this to you. Now those colors are quite nice, and that's the reason why I have a DIC microscope, is so that I'm able to, over YouTube, can give you nice colors. But most of you are going to probably see it like this. Okay, so that is regular bright field. So just so that you're able to see the difference here. So these are the natural colors right now, and you see that actually many of the, or most of them, are actually transparent. And the bright field does again have the advantage that by looking around it, you can actually see that those structures that have, for example, a green color, these are, for example, could be plants, for example, algae, cyanobacteria maybe. Yeah. So bright field, because it produces the natural colors, is also useful for its own purposes. But then again, if you put it in here, it swallows so much light that I have to go up. It looks like this. Yeah. So, if I'm just reading this here. Yes. Okay. Yeah. So there are no specific questions now. For me, so maybe, I don't know, maybe I'm just going to try another one here. Okay, I'm going to just maybe I'm able to find something slightly different. Maybe I'm going to try to get a little bit of you know what, I'm going to use my pipette now. Maybe I'm able to. I'd like to see what this is here on the... No, I used oil here, right? Yeah, I have to change tip. I'm going to use a different tip because it was actually contaminated with oil. So, and there is this white stuff floating around on the surface of the water. And usually there are also plenty of bacteria in here. So I'm going to have a specific look at this. I'm going to put this into the trash. I do not like to have bacteria, unknown bacteria on my desk. That's why it's always a good idea to have observed basic hygienic principles. Okay, so let's put this all away. So let's give this one a try. Let's see what we are able to find here. Again, we need a microscope view. Okay. This is actually much nicer. You see, at a lower concentration, we're actually able to... And I have to tell you that for bacteria, those dots that are floating around, these are either small ciliates or large bacteria. Because, but I do see some spiral-shaped bacteria as well. So you see, this is actually much better here at a lower concentration. Are those tiny moving things bacteria? Most likely. Some of them are, and I can tell you those that definitely are. Have to go, because actually some of them are pretty large bacteria actually, because I'm able to see them also quite well under low magnification. But look, definitely bacteria. So I'll show you now where the bacteria are. If you look at, I need an arrow now. Those long, tiny, thin, some of them are spiral shaped in the background. These are all bacteria. Those larger dots that are floating or swimming around here could be also small flagellates or ciliates. Yeah, but those tiny in the background, those tiny, long, sometimes spiral-shaped structures, these are all bacteria. Kind of illustrates a little bit the size difference here. Yeah. Okay. Yeah. So let's go down a little bit again with the magnification. What I would like to do now, here, so this is basically, this was now a sample from the surface of the jar, and obviously at the surface the oxygen concentration is higher, so we can already see that there are also some other microbes swimming there. Sometimes they swim to the top because this is where the oxygen concentration is the highest, and sometimes you see them gather around algae which produce oxygen. But as you can see here, I don't see many intact algae here, everything's pretty decomposed. Okay. Let me find something. Those long worm-like structures, sometimes, these are not worms, but also cyanobacteria. Those long worm-like structures. Oh yeah, here we have a higher concentration again. This sometimes what you're able to observe is that over time some of the cells, some of the microorganisms, they either collect somewhere, like over here, or they start to move collectively like a swarm into one direction. And in many cases what they do is they move towards oxygen. Usually on the side of the cover glass the oxygen concentration is the highest, and this is where they will usually start to gather. So they will actually move to the edge of the cover glass, and you can actually see this also quite nicely using time-lapse. So if you take a video, you can actually sometimes see that the swarm of bacteria is moving across the slide collectively. Yeah? So, okay, I'm just reading the comments again. The audio, some people evidently have a little bit of an echo in the audio. Okay. Hope that all of you are able to understand me. So this is a nice example of what happens when a sample starts to decompose. Usually if you have a sulfury smell, and this is usually or a smell like rotting eggs, this is usually hydrogen sulfide, and usually it forms when the sample becomes anaerobic, when there is too little oxygen present. And then sometimes hydrogen sulfide is formed, and this gives it a foul smell, and generally this is not a good sign. Here we see quite nicely again a collection of bacteria in the center. And some of them stop moving, and I don't know why. It could be that they're compressed between the cover glass and the microscope slide, that simply their movement is physically limited or inhibited. Okay, we can go up a little bit with the magnification here. Yep, and here we go. So this is a little bit. So it like this. Okay. Okay. Any questions from your side? Maybe I have. Let me see if I showed you everything already. These are the sand sculptures. We watched this already. This was the bird. The seagrass I talked already about. This one was from the Marine Biological Center there. And the seashore. I think I showed you everything. Is there anything else I wanted to show you? I think this is pretty much everything that I have. There has been a question once maybe I'm going to do that as well. How does this sample, which is now under my compound microscope, how does this sample look like under the stereo microscope? So are stereo microscopes suitable for actually observing samples like this? And I will tell you probably not so, because the magnification is not high enough, but we can try it out. Because many of the plankton things that I showed you before actually are multicellular animals, are quite large. So we turn off the light here, we switch on the light here, and I'm going to turn on the bottom light. I need to focus a little bit. Yeah, and you can see that essentially, yeah, we're able to see some plant parts. The resolution is also not quite good enough right now, but nah, stereo microscopes are not suitable. Okay, because the things are simply too small to be observed, and yeah. So stereo microscopes really benefit when you want to look at samples that essentially are opaque. Okay, like for example, the sand from before. So also kind of illustrates a little bit that every specimen has its, every microscope has its own world, as you used to say. So you see that sand grains work quite well with stereo microscopes. As a matter of fact, when you have light coming from the top, okay, yeah, and if you put them under the compound microscope, sometimes you're not able to see very much. Yeah. Yeah, so this is now basically, yeah, with the compound it looks a little bit washed out, everything. So different microscopes basically are best for different different samples, of course. So okay, yeah. Again, one here. I'm driving around. It's hearing but not watching closely. Oh, okay. So somebody's. Thank you for doing this live stream. Okay, well. Happy to be of use. Yeah, if you're not able to watch the live stream, then of course you can later on always observe. You can later on always observe the video later on. By the way, I do on my homepage, on my website. It's not been very active, but on my webpage, I also started some time ago doing podcasts. So basically audio only, where I explain certain things. Maybe you're also interested in listening at those. So in some cases, I've been recording videos where I'm explaining certain things, and then I also put it onto the podcast. So on my microbehunter.com website, there are a couple of podcast episodes which are audio only, and I've made them in such a way that there is no need to watch an image. But usually these podcast episodes are a little bit less observation based, obviously, but a little bit more technical, where I explain a few things and so on. Yeah. Yeah. So here are pretty thin. Okay, the mostly keratin with the outside and only, yes, basically here. Yeah. Yeah. Here basically is protein. Yeah, so it's not based on, it's not cells. It's keratin, which is a protein which is made by cells, but itself is not cell. Do Baltic microorganisms different from Austrian ones? I will tell you the following. Depends on the microbes. Indeed, there are some places, I read this somewhere, where there are some ponds that are basically where a protozoologist, Mr. Feusner, he already passed away a couple of years ago, but he was one of the most world famous protozoologists. He was able to characterize a protozoal species there that could not be found anywhere else. So sometimes the ecosystem is so highly local that you find only species in a specific ecosystem. So if you ask, are certain microorganisms different in different areas, then I will tell you, will probably have to tell you, if you look close enough, and you're going to probably find microorganisms that are highly specific to a certain region. So maybe not generally, many of them can be found all over the place, but some of them can be highly geographically specific. Yeah. Podcast. Yes, I did make a podcast. I'm still occasionally working on it. Yeah, if you feel that podcasts are also valuable, then I can do more of those. With the podcast, I was a little bit limited because I cannot show you the things, and microscopy is a very visual thing. So the podcast is mostly on microscopy related things which are more technical. Or talk about optics, or talk about other things like this which do not need a picture. But if you check the web page, then you're able to find also the podcast there. I've got a couple of episodes, not updated it recently. Okay, people. It's 1 hour 10. Yeah, I'm finished with all of the specimens that I wanted to show you. I mean, there is another thing. No, actually, there is one specimen left. Is there? Yeah, no. Oh, this is another sand sample. No, I'm basically, I've got all of my specimens covered right now. Okay. So it's 1 hour 10. So I think what I'm going to do now is I'm just going to call it a day for today. I would like to remind you again of this microscopy 300 years. And yes, of course, I forgot. I also want to say a big thank you to all of you, because just a few days ago, last week, the YouTube channel has all of a sudden exploded, and there are now over 100,000 subscribers. And so YouTube is now going to send me the silver play button. And yeah, I had to basically confirm that I want to have it, and then I ordered it, and in the next couple of weeks they said they're going to send it to me, and of course I'm going to put the silver play button also under the microscope when it's here. But I would like to, of course, extend a big thank you to all of you for supporting the channel. Maybe something that some of you might not know, and that is that one of the reasons why the channel exploded recently is because I started a little bit more regularly. I started publishing YouTube shorts. Yeah, so this way I was able to reach a different audience as well, mostly also a younger audience, and this also contributed to it. So if you were interested in also YouTube shorts, then you can please check this out. But I will continue to make also the regular videos, but I have not done so over the last week because I was simply not here. But of course I'm going to keep the channel also up to date. Okay, yeah, so that's basically what I've planned. From which Baltic region did you collect the samples? Okay, no, it was the Baltic Sea. The Baltic Sea, but I was not in the Baltic states. I just wanted to show you again. You join in later. The Baltic Sea is this ocean over here. Okay, but I was here in Germany, northern Germany. Yeah, so, but in English it's called the Baltic Sea. And I was here in northern Germany for a week, on holidays to escape a little bit the heat of Central Europe, because there was quite a heat wave right now, and so we moved for a week. We looked at this place up here, and we did a little bit of sightseeing up there. Yeah, and so this is basically. I'm just going to call it quits for today. I wish you all the best. Next week, I plan to do, of course, another live stream. Okay. If you have any specific wishes or recommendations, please be open. Yeah, I'm free to write them. I'm always happy for suggestions. Okay. Yeah, and the last couple of questions. How many days do microorganisms stay alive? That is a very interesting question. The thing is the following: microorganisms generally do not have a built-in lifespan like we humans have. Okay, so what happens is you can say they stay alive until the conditions are until the conditions are bad that they're dying. I mean, so for example, if it becomes too hot, then they're going to be cooked and then they're going to die, right? But microorganisms do not have a built-in lifespan like like animals have, for example. So what happens is that the microorganisms, when the conditions are favorable, they simply will divide, and then there are two of them, and then they will divide again. Yeah? So in that sense, you could actually say that microorganisms have an unlimited lifespan. Because they keep on dividing and then you have many of them. Because this concept of individuality, like we know it for humans, it does not exist at that level. So this is a little bit interesting. It's getting philosophical now a little bit. But microbes, microorganisms, single-celled microorganisms concerning the lifespan cannot be really compared to those of animals. Also because they keep on dividing, and if the conditions are right, they will continue to live and divide. And if the conditions are bad, not favorable anymore, extreme environments, they might die. Obviously, but okay. Last question is so inside the container, how long can you store it? Okay, I'll be honest with you. It depends a little bit on the sample and maybe a mistake that I made. So in those plastic containers here. And then I'm really going to stop here. When you collect samples, and this is again a mistake that I made, is I filled up the sample quite high with water. I stuffed it full with algae, which kind of blocked the light again. And then after a day, it already started to smell bad. So if you want to collect water samples, then do the following: use only very little water. Okay. This gives it enough air up here to allow for oxygen and carbon dioxide exchange. Open it regularly and to allow fresh air to go in. It still smells bad. I just wanted to show you something. This one over here, I need to reach over. Okay, I've got a cable. This one over here has been standing on my window now for, I don't know, 2 weeks. It's a water sample that I collected, and it still looks green and fresh. And you know what? I could actually try maybe to take a sample here and put it under the microscope. So this has not been closed off. Just let it stand here. Let's try this. Why not? I do not want to use this here, the tweezers here. I'm going to contaminate this. I'm just going to use the scissors here. Let's have a look of what I'm able to find here. Okay, so this has been, so it does not smell bad. And see, actually I wanted to simply, because I'm curious, now I've become curious. Okay, I don't have tweezers, you know what? No, I do have some tweezers. No, where are they? Just a second. I do have some other tweezers here. Yeah, here, let's take those. Okay, let's have a look what we're able to find here. Because this sample has been standing here now for, I don't know, over 2 weeks, 3 weeks maybe. Okay, take a little more. There's also some solid material now present. And so keep the containers open. That is what I can recommend. Don't add too many plants or too much material, and keep it open. Let's have a look. I have no idea what to expect, but now I've become curious myself. Let's remove the sand. Yeah, water flea. What is this? Oh, an ostracod. Here, a worm. I think you get the idea. Yeah. 2 ostracods. Iolosoma, that's the name of the worm. So basically just like at the beginning. Lesson: keep the container open. And when the water evaporates, simply add a little bit of more water. Iolosoma, that's the name of the worm. And it's an oligohete worm, and they're pretty fun to look at. So yeah, that was somewhat of an unexpected little thing here at the end. Okay. Yeah. So, but do you sterilize your containers and reuse them? It depends. If those containers are so cheap that you can just throw them away as well. If I rinse them out, and if they're too difficult to clean because things are sticking on the inside, I simply throw it away. Yeah. Otherwise, if it's possible to kind of rinse it properly, then I say why not. Yeah? But I also do not want to always cross-contaminate, yeah? Because then, yeah, I'm kind of losing the original nature of the sample if I'm introducing something else. Yeah, yeah. So that's it, folks. I'm going to call it quits for the day. Thank you for having joined the live stream again. Okay, and yeah, see you around next week. Happy microbe hunting, everyone, and bye bye.